Yeah, there are two types of Oracle architecture. One is physical structure, and another one is logical structure.
Hmm. Okay.
In
What
physical
contains in
structure,
physical
there are
structure?
control file, data file, and reader log file.
Okay.
Yeah, and logical is instance,
Hmm.
and there are two types: memory and background process.
Okay.
Memory is called for another name SGA. SGA stands for System Global Area,
Okay.
and and memory components are database buffer case and
Mm.
read log buffer case and shared pool. There
Yeah.
are another
Yeah.
data dictionary case and library case.
Yes. Yes. Exactly.
Yeah,
And
and
the
the
background process.
background was there are seven.
Mm.
There are, seven is there, and one is
Mm.
server process, and
Yeah.
second one is SMON system monitor, PMON process
Yes.
monitor,
Okay.
database writer. Yeah,
Okay. Fine. 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 Okay. See, as per yesterday, I have discussed about this architecture. So, see, actually, Oracle server architecture consists of two major components or two major structures like physical and logical. Physical in the sense our physical files. That means our database files called control file, read log file, data and data file, password file, parameter file. Okay, or Oracle home binary file, network related files, and yeah, these are the physical files we call. Okay, and coming to logical structure is nothing but an instance. Okay, it is an instance. Instance in the sense, in general terms, it is a like it acts like a RAM actually. Okay, so see, this is a instance. Why this is called is act as a RAM means here the actual process will run. Okay, see, if you think this is like a engine. Okay, so what are the requests coming from outside of the database? Okay, those requests will be processed here. Okay, and those requests will be processed and it will get the information from the data files, or if it is in the memory it will give it from the memory and it will forward to the user. Okay, so this is the instance consists of three major memory components. One is shared pool, second one is database buffer cache, third one is read log buffer cache. Okay, this is the architecture actually. This is the architecture. Okay, is this fine?
yeah,
Okay, so as I said, this is a logical structure. In this logical structure, we have other optional memory components like large pool, okay, Java pool, streams pool, and the with the background processor called server process, okay, SMON, PMON, okay, DB writer, check pointer, log writer, archiver, okay, recovery, MMON, MMLN, okay. These are all background processors which will use it to support or which is used uh, to help the these memory components to process in the process. Okay, so we'll look into uh, each structure today in brief. Like today, so this is the introduction. Oracle structures a database. Okay, both physical and logically. Both physical and logically, Oracle structures a database. The Oracle database physical structure is the set of operating system files that stores information on disk. This is called physical files. Okay, the files which are storing in on the disk, our file systems, on the file systems, those are called physical files. Okay, the files which are stored in logical format. In the logical format, in the sense, tables, right? What are the data inserting into the database? Those will be stored in the form of rows and columns under one table, right? So that kind of structure is called logical structure. What is Oracle physical structure? An Oracle physical structure consists of following files. What is that one? Data files. These files store the database information that a firm or organization needs in order to operate. This means this is the data file where the actual data of any organizations or any persons or any objects information will be stored. Okay, in the form of rows and columns, that is called tables. That tables will be stored in the data files. Okay, control file. Control file, in this sense, this is the most important file, and this is the heart of the database. Actually, why it is calling the heart of the database means, what are the operations happening inside the database? Okay, those information, okay, that information of the about that operations will be stored inside this control file. Okay, everything like what is the creation of that particular operation or creation of the database, and the SCN, if it is taking a backup information, what are the things happening inside the database, those informations will be stored in this control file. Okay, in this control file, like the timestamps, when was the operations happening, the timestamps. Okay, if the database name, okay, and SCN numbers and other more backup information, all these things will be stored inside this control file. So that's why this is called heart of the control file, and this file is very important. And redo log files, redo log files are the files which are used for recovery purpose. Okay, if something happened to our database and database got crashed, okay, for suppose, see, I'm taking this MS Paint. One second. Oh, oh, what's happening here? Okay. Okay, see, I'm talking about redo log files, right? Why redo log files are needed, and what kind of information is stored in this redo log files. I'll let you know. See, let's consider this is the database. Okay, this is the database. Just consider as a database, and here in the database, okay, regular transactions will be taken place, and this growth of the data inside the database will be increased. Okay, in timely manner. Okay, it's growing. Okay, so whenever a user whenever a user is coming and inserting the data, okay, and he is updating the data, so when he is updating the data, the new data information will be processed in the database buffer cache. Okay, database buffer cache. Okay, whenever a new data is processing in the database buffer cache, that information will be stored in redo log buffer cache. That information will be stored in redo log RLBC. Okay, so here the I'm typing you consider as user. So this user is coming and inserting some data, so it was updating, and still it is on updating. Okay, at this point of time the database got crashed. Okay, the database got crashed, but we have backup at this point only. at this point we have backup. So we can restore the database until this point only. Okay, we can restore the database until this point. Why? Because our backups are there until this point. So these backups are we have restored, and we bring back the database to this point. What about these 2 points? What about this data which was updated at this point and at this point? These 2 points, it won't restore, right? Why? Because we don't have backup of these things. Okay, in that case, by applying the redo logs, we can bring back the data at of this point and of this point. So for that purpose, redo logs are important. The main purpose of redo logs is for recovery purpose. Okay, whenever a database crash or any human errors, due to any human errors or disasters happen, if the database was shut down uh, inconsistently, then by applying these redo logs we can bring back the database into the exact crash point. Okay, for suppose the database was crashed at 12:11:1. Okay, so I can bring back the database at that particular point of time by using this redo log files. So that is the importance. Okay, archived redo log files in the sense, what are the redo log files are processing? Okay, it will take one more copy and it will save it into another location. Those are called archived. That means the redo log files will be archived into another location. See, these files are used to these files are, we can, okay, these by using these files also we can recover. These files are used to recover the database if there is some failure in the disk. Okay, these two files are used for recovery purpose. Why archived also used for recovery purpose in the sense? Why? Because in it will come to know earlier, but just keep it in mind. Like where is this one? Okay, so this is my redo log buffer. Okay, this is my redo log buffer.
శశి
Yeah,
ఇప్పుడు
tell
వీడియో
me.
లాగ్ ఫైల్స్ లో మనం ఏమన్నా చేంజెస్ చేసిన తర్వాత సో ఆర్కో వీడియో లాగ్ ఫైల్స్ లో కూడా అది చేంజెస్ అవుతుందనా?
Yeah, అవుతుంది. కానీ
ఓకే
చేంజెస్ అనేవి రీడో లాగ్ ఫైల్లో మనం ఎటువంటి చేంజెస్ చేయం. ఓకే,
ఓకే
నేను అందుకే అంటున్నా, ఇప్పుడు మనం జస్ట్ వాట్ ఈజ్ వాట్ అని తెలుసుకుంటున్నాం కాబట్టి అక్కడతోనే ఆగిపోండి. ఎందుకంటే నేను మీకు ఒక యూజర్ రిక్వెస్ట్ వచ్చినప్పుడు ఫస్ట్ ఎలా ప్రాసెస్ చేస్తుంది, ఫస్ట్ స్టెప్ ఏంటి, అలా స్టెప్ వైజ్గా ఒక ప్రాసెస్ జరుగుతుంది. ఆ ప్రాసెస్ అనేది నేను ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే, ఫస్ట్ మీరు ఈచ్
ఓకే
కాంపోనెంట్ దాని పర్పస్ ఏంటని తెలుసుకున్న తర్వాత నేను ఆ ప్రాసెస్ ఎక్స్ప్లెయిన్ చేస్తే మీకు ఈజీగా ఉంటుంది. ఓకే, సో అప్పుడు మీకు ఎగ్జాక్ట్గా అర్థమవుతుంది. ఇప్పుడు ఏంటంటే జస్ట్ వాట్ ఈజ్ వాట్. ఓకే, షేర్డ్ పూల్ అంటే ఏంటి, దాంట్లో ఉండే లైబ్రరీ క్యాచీ అంటే ఏంటి, దాని పర్పస్ ఏంటి, ఇవి చెప్తాను. జస్ట్ అర్థం చేసుకోండి. నెక్స్ట్ మీరు చదివితే అర్థమైపోతుందిలేండి. ఓకే, సో ఇది నా RLBC అంటే రీడ్ లాగ్ బఫర్ క్యాచ్. రీడ్ లాగ్ బఫర్ క్యాచ్. ఈ రీడ్ లాగ్ బఫర్ క్యాచ్లో నాకు ఈ రీడ్ లాగ్ బఫర్ క్యాచ్లో నాకు ఒక సారీ రీడ్ లాగ్ బఫర్ క్యాచ్లో నాకు ఆన్లైన్ రీడ్ లాగ్ ఫైల్స్ అనేవి ఉంటాయి. ఓకే, ఆన్లైన్ రీడ్ లాగ్ ఫైల్స్ అనేవి ఇవి నా ఆన్లైన్ రీడ్ లాగ్ ఫైల్స్. ఓకే, ఇప్పుడు నెక్స్ట్ ఇక్కడ నాకు డేటాబేస్ బఫర్ క్యాచ్ ఉంది. రికార్డ్ చేయట్లేదా? ఓకే. ఈబీబీసీ ఇది నా డిబిబిసి. అంటే ఏదైతే యూజర్ రిక్వెస్ట్ వస్తుందో అది ఫస్ట్ వచ్చేసి ఈ మెయిన్ కాంపోనెంట్ డిబిబిసిలో ప్రాసెస్ అవుతూ ఉంటుంది అనమాట. ప్రాసెస్ అవుతూ ఉన్నప్పుడు ఓకే, ఎప్పుడైతే ఈ డిబిబిసిలో ఒక డేటా ఉందనుకోండి, ఒక యూజర్ డేటా 1000 ఉంది. ఓకే, వాడి శాలరీ 1000 ఉంది. వాడి శాలరీ వచ్చేసి అప్డేట్ చేస్తున్నాడు ఎంతకి? 5000కి. ఓకే, there is a user data of salary called salary, that is 1000. So he is going to update the salary to 5000. That means he is updating his salary from 1000 to 5000. Then these, what are the changes happening? Okay, this 1000 to 5000. Okay, these changes will be recorded into this redo log buffer cache. Okay, this is a memory. It will come and it will process here and it will push that value into one of the online redo log file. Okay, online redo log file. Like that, each and every time what are the transactions happening inside the database buffer cache, those will be come into this redo log buffer cache and it will fill up here. Okay, the data is writing and this online redo log is got filled. Then what will happen? It will switch the file to the second one. Okay, here log switch is the terminology. It will happen. Okay, log switch will happen. Log switch means it will shift to the other available file, online log file. Okay, so this is filled up, so this is empty. Now it will switch to the other available file. So now it will write, it will start writing. While it is going to start writing this filled file, what will happen, right? Okay, we have a RQ log location. So this file's data will be go and save here. Why? Because if this second file also it got filled, then again it will switch back, then this data will be overwritten. Okay, before doing that only, whenever a log switch occur, okay, these files will be archived into this RQ location. Whenever a log switch happen, these files will be archived to this location. Okay, so that if this file also got filled and if it again switch back to this log file, and it will, if it is overwritten also, no issues. Why? Because already the data in this log file is saved in my archive. Okay, it's saved in my archive. So this data will be saved and recovery for recovery purpose, we have a data in our recovery, archive recovery. Okay, so that is the thing. So that is archive redo and parameter files. Okay, parameter files is used to set up our data files. Okay, set up our data file configurations. Okay, what are the configurations, like how much space our database memory needs. Okay, this memory is there, right? How much space this SGA, complete SGA, system global area needs. Okay, and how much space our memory sorry, the system global area needs, and how much memory this large pool needs. Okay, in the same way, where is our control file should be located, all these things will be kept in our parameter file. Okay, those are called database parameters. Okay, and password file is used for our database authentication purpose. Okay, database authentication purpose. And alert and trace files. Alert log means, okay, whatever the things we are doing inside the database, those all things will be recorded in our log file called alert log. Okay, this is like a live file If you start the database, then this alert log will be updated with those details. Okay, so this is very friendly file. Okay, it will be very helpful for us. Why? Because what are the things happening in the database, we can easily monitor from this file. Okay, so and then we can easily come to know what is happening. Okay, if there is any internal errors, okay, happening inside the database, then those errors also will be recorded here in this alert log. So that's why it is called a friendly file. Okay, it's a friend of DBA. And what is logical structure? Logical structure consists of, as I said, this is the logical structure. Okay, system global area. And what is inside the logical structure? One second. Why table space, all these things? Okay, sorry, some slide mistake actually. This should not come. Table space segment 5. Actually, as I said, the logical structure consists of instance. Okay, the logical structure means the instance. Instance consists of system global area plus background processors. Okay, system global area plus background processors. The instance and database files. What is instance? See this slide. Oracle server, instance, and database files. We already discussed about the database files. We are going to discuss about this instance. What is an instance? Instance is nothing but it's a combination of memory plus background process. Memory means system global area. Okay, and additional. Okay, yesterday I forgot to mention like program global area. This is an additional one. Okay, additional temporary memory area. Okay, whenever a user process is created inside this database, this will come when this user process is completed its task and it terminated from the database, then this will be unallocated. Okay, so a database instance is an interface between client application and the database. Database instance means it is interface between the client application and why? Because all the client requests will be processed inside this instance, right? So that's why it is called an interface. Three main parts like SGA, PGA, and background process. PGA is a temporary memory. Okay, as I said, whenever a client request come into the SGA, then this PGA will be allocated for doing some kind of sorting operations. Okay, doing some kind of sorting operations. So this is the memory, and the components of the SGA is like what are the components? Database buffer cache, redo log buffer cache. See here. Components of SGA. Shared pool. Again, the shared pool consists of library cache and data dictionary cache. Okay. And database buffer cache, redo log buffer cache. Additional components, large pool, Java pool, strings pool. See, that's why this SGA is in one box. This SGA is in one box. And PGA, this is like a temporary process. Okay, whenever a user connection is established, then this will be dedicatedly allocated to the particular user request. Once the request is completed, this will be unallocated. So this is a temporary. You guys are following, right, what I'm saying? Or still any
Yes.
confusions or anything? Pratima, Srivani, what about Tulsiram?
Okay, sir.
Okay, so instance is this. Okay, memory components like SGA, PGA, and UGA. One more optional thing. Okay, This won't be much useful in this single server, I mean single instance. So what is SGA? Okay, this is SGA is a system global area which will be allocated when Oracle instance starts up. Okay, whenever our instance starts up, instance in the sense the database machine. Okay, the database machine which will open up the database components to process, okay, to process the user requests and to store the data inside the database level. Okay, for that purpose, that's why it is called database engine. It is a large part of memory that all Oracle background process access. Bro- with the help of background process, all these requests will be processed from one component to the other component. Like as I said, uh, here from database buffer cache to read log buffer cache, how these updates are going. Okay, by using the background process. Which background process? Server process. Okay, server process will push this updates to read log buffer cache, and from read log buffer cache, which background process will push to the online read logs? That is log writer. We'll come to know that one. PGA. Okay, this is allocated when a server process starts up. Okay, server process starts up in the sense whenever a user request comes inside the uh, instance. Okay, this PGA will be allocated, temporarily allocated to that particular user request to help to do some, if the user request is doing some sorting things, those things will be taken care by this PGA. Okay, UGA. Okay, this is also same allocated when a user connects to create session. Okay, whenever a session is established for user, this also will come, but in single instance this UGA is not usable. In RAC administration we'll come to know this UGA. Okay, see, this is the SGA. What is SGA and its components? System global area is a shared memory area. It is a shared memory area. This whole system global area is shared with different components called shared pool, buffer cache, read log buffer cache, large pool, Java pool. See, with these memory components, it was shared. So that's why it is a system global area is a shared memory area that contains data and control information for one database instance shared by database process and by users of the database. Okay, that contains data and control information for one database. For one database, there is a dedicated system global area. Okay, for one database, only one SGA will be there. Here, the read and write operations will take place. The read and write operations will take place. Okay, and the system global area will be allocated whenever an instance is starts up. Okay, so it is read and write memory area. Why? Because it is supporting the read and write data. Okay, the SGA is allocated when instance started up based on values specified in the installation parameter file. Okay, based on the installation parameter, as I said, right, parameter file, what is how much size this SGA has to give, and what is the sizes it should be splitted to shared pool, buffer cache, read log buffer cache. Okay, depends upon the parameter file, that parameter file. Okay, SGA underscore target is the parameter file. Based on that parameter file, okay, this size will be dedicatedly allocated to the other components within the SGA. See, instance started up based on the values specified in the initialization parameter file and released when it is shut down. Okay, it will be released. Obviously, it will be released. Okay, when the machine is switched off, nothing to do, right? Then SGA also will be released. So the SGA is a group of shared memory structure. The size of the SGA can be established by a DBA. The size, one second. So this SGA size will be calculated and assigned by a DBA. We will decide how much SGA we have to mention. Okay. But mostly instead of DBA, architects will be there. So they are the people who will collect the requirements of the business, and they will design the database and they will give it to us. So mostly what are the details they will pass to us, will simply, while configuration, will simply pass that value to this particular SJ. For suppose they have given for one business model like 10 GB of system global area, then we will simply mention that 10 GB in our parameter file. Okay, see, these are the parameters like the size of the SJ can be established by a DBA by assigning a value to parameter file. Okay, what is the statement saying means, what are the values we are getting from the architect or some other sources, that will be assigning in our parameter file. Okay, in our parameter files with the parameter name sj underscore max underscore size. This means here the total allocation we are giving. For example, they are giving 10 GB, then we are giving here 10 GB. But according to the database usage, we will allocate only 5 GB initially. Okay, then one more parameter is there, sj underscore target. I think that one I have missed it here. Okay, so uh, I'll show you while doing the database configuration. SCA max size means the total size allocated for this SGA. That means 10 GB. So within the 10 GB, I want to queue initially 5 GB. Why? Because right now the database usage of the users is very less. So 5 GB of memory is enough to process the user's data. So for that one, I will give sg underscore target is equal to 5 GB. Then that 5 GB will be utilized and this will be in standby. Okay. If the 5 GB of data also it's crossing means, then I will increase the size. But I can't increase the size beyond 10 GB. Why? Because the SGA max size parameter is 10 GB, so I can't increase beyond 10 GB. Until 10 GB only I can increase. If you want to increase the beyond 10 GB, then I have to change this size here first. SG underscore max underscore size. Okay. And as we know, what are the components of SGA? Database buffer cache, redo log buffer cache, shared pool. Shared pool again includes two components. One is library cache, the other is data dictionary cache, and additional like Java pool, streams pool, large pool, so on. Okay. And next one, PGA. Okay. Different from the SGA. PGA stands for Program Global Area, which is a different from SGA, which is available to all processes. The process means user requests. Okay. PGA is private memory. PGA is a private memory area allocated to each session or user process connecting to a database. See, as I said, whenever a user is trying to connect to the database, okay, this PGA will be allocated dedicatedly to that particular user session. Okay, and is allocated when session started and releases when session ends. When the user request is completed and he terminated from the database, this PGA also will be terminated. That is the statement. Allocated when the session started and released when the session ends. Okay. So PGA is a non-shared memory region that contains data and control information exclusively for use by an Oracle process. Okay. This memory which is allocated is a temporary memory. Okay. At that time frame, at that user processing time frame, the data and control information will be stored here. Once the user process is completed and released from the database, this information also will be vanished out. Okay. So it is created by Oracle database. When an Oracle process is started, only one PCA exists for each server process and each background. Only one PCA is dedicatedly allocated to that particular process. Okay. See what are the contents like? See, short shorting operations or hash zones conditions will be there so many. Okay, so all these things will be taken care in this PCA for temporary purpose. Why? Because those are all temporary purpose. While the process is happening, those things will be happen. Once the process is completed, those things will be vanished out. Okay, those are not a permanent operations. So those kind of temporary operations will be taken care in this PC for that particular user system. It's called PCA. Next, contents of PCA is private SQL area. Okay, these are the contents, right? Short area, hash area, bitmap, session memory, persistent, runtime. Okay, so this was divided into two. Short area, hash area, bitmap area is considered SQL work areas, and session memory and persistent area and runtime area is private SQL area. So what are those? Private SQL area contains data such as bind information and runtime memory structures. Okay, the whole process happening for that particular user runtime will be stored in this private SQL area. Okay, it contains persistent area which contains bind information and is freed only when cursor is closed, and runtime area which is created as first step of an execute request. Okay, here bind information in the sense, okay, it is kind of an um, meta information of that particular user. Okay, this area is freed only when statement has been executed. Once the statement is executed, this area will be freed. Number of private SQL areas that can be allocated to a user process that depends upon the open cursor's parameter. Again, parameter came. Okay, installation parameter. Okay, open cursors. Here, cursors in this sense, memories. Okay, cursors in this sense, small kind of memories. Okay, that will be dedicatedly allocated to that particular user request when it is going to processing in the database. Okay, and session memory consists of memory allocated to hold a sessions variable and other info related to the session. Okay, that particular sessions information will hold in this area for temporary purpose. SQL area. What are this? If the user request is performing some SQLs, okay, some select SQL, okay, the data accessing language I said, right? Whether he is updating, whether he is inserting, whether or he is using the select statements, okay, those kind of statement has each behavior. So those kind of operations or behaviors will be hold in this particular area. Okay, will be hold in this particular area also, in this area. Either that operation might be a short operation, might be a hash operation, or might be a bitmap operation. Those operations will be hold in this SQL worker. Okay, that is the description. Brief about SGA and its components. Brief about SGA and its components. Why these all slides are altered? I don't know. Sorry guys, I think some this is a old one or something. What is this one? One second, give me a second. Mhm. Oh, okay. Oracle architecture. You just go through it, okay? It's just those are all just statements. Oracle architecture, physical structure, data files, passwords. Okay, this fine logical structure. I think this is some kind of old file. Brief about SG and its components. Where is this component? Mm, Okay. Some slides are changed. Okay, so we'll see. Control file, data file, retrieval file, RQ log file, pass file. Okay, these logical structure, instance of this instance, memory components plus backup components. Okay, leave those slides. First we'll talk about these memory components. Okay, we'll discuss. So the first component is shared pool. Okay. Okay. So from memory components perspective, the first component is shared pool. Again, the shared pool is divided into two components, two sub components called large pool. Library cache and data dictionary cache. These two are the main components, and additional components are there like server result cache, okay, and private SQL area not required. Okay. So first thing, what is this shared pool? What it contains? See, contains used to store most recently executed SQL statements, most recently used data definitions. It consists of T key performance like library cache and data dictionary. Basically, the shared pool is mostly used to store the recently executed SQL statements and recently used data definitions. What is that means? In library cache, okay, in library cache, what are the statements, user passing statements coming, right? Those statements will be parsed. Okay, and those statements will be parsed, and here it will check. Here it will check whether a particular statement is executing for the first time or it's already executed. If it is already executed, it simply takes the output and it simply passed to the user. Okay. Or if the statement is executing for the first time, then some kind of operations will happen. What are those things? Means first of all, it will generate one execution plan for that one by the optimizer. Okay, and it will generate one execution plan, and it will assign one plan hash value. Okay, plan hash value that will be stored in this library cache. Why? Because if the same statement again one more user is going to execute, means at that time that particular execution plan will be holding by this shared library cache, so that that statement comes to know to the sorry uh, that statement is already processed, so the output is already saved. So for that statement, that output particular output will be given to that user immediately without any delay. Okay, for that purpose this statement this library cache memory area is there. See? Okay. The shared pool is a memory structure that is shared by all system users. The shared pool stores the most recently executed SQL statements and PL SQL codes, system parameters and data dictionary information. This is because some system users and application programs will tend to execute the same SQL statements often. Same SQL statements will be processing inside the database. Okay, which was used by those application users. For suppose the statement like select star from $V database. Okay, that is the common statement for each and every DBA to know the information of the database. That is the common statement. So if the database is created for the first time and this statement is executed for the first time, it will, as I said, here in this library cache, the optimizer is a program, okay, that will generate one execution plan for that particular statement. It will store the results of that execution plan. Okay, so whenever again one more user come and hit that same statement like service start from VW database, then again it won't process. Okay, again it won't prepare one execution plan and it won't collect the results. Already the results are collected, so those results will be given to the user immediately. Why? Because already the execution plan is dedicatedly stored here. Okay, so the shared pool is involved in almost every operation that occurs in the database. Whatever the first step, it will go to the data dictionary, and after some validations, it will go to the library cache. So the first step is like here. Once it got passed here, it will go to database buffer cache. Okay. The shared pool is involved in almost every operation that occurs in the database. For example, if a user executes a SQL statement, then Oracle database access the shared pool. Then Oracle database access the shared pool. And this shared pool size will be mentioned in the parameter file. Okay, based on the SGA max size. Default value of the parameter is 8 MB on 32-bit platforms and 64 MB in 84-bit platforms. So 64-bit platforms. Increasing the value of this parameter increases the amount of memory reserved for the shared pool. Reserved for the shared pool. That means SGA max size. You can alter the size of shared pool dynamically with the alter system command. Using this command, we can alter the size of the shared pool. Okay, but see, here the note is there. You must keep in mind that total memory allocated to this SGA is set by SGA target parameter and may also be limited by SGA max size. Okay, and since the shared pool is part of SGA, you cannot exceed the maximum size of the SGA. Okay, we can't increase this shared pool size beyond the size of SGA. Why? Because this is the part of SGA. So what is the amount of memory allocated to this SGA. Okay, within inside of that memory itself only we have to allocate this one. But in real time, we don't allocate, only the Oracle instance will take care. Okay. Uh, Here example will be there. Whenever you connect to a database as a SysDBA, if you press show SGA, then it will show. See, the total SGA system global area is this much. That means how to calculate this one? It was showing as bytes, right? So you have to come from the left side. First three digits are bytes. After bytes, what is that? Kilobytes. After kilobytes, what is that? Megabytes. After megabytes, gigabytes. So this is around 1 GB. So within this 1 GB, the fixed size is this much, variable size is this much, and for database buffer cache is this much, and read log buffer cache is this much. Like that, it will allocate within this 1 GB. It will uh, separate the sizes, and it will allocate to each every component. But sorry guys, actually don't know. These all are amended actually. Slides are going. Slides are not in order. Let me check actually. Oh, this should come here. SGA max size. What is it? Okay, how read log large Java full, okay, this one seems good. And then background colors. Okay, additional background. Is it clear? I think you guys are in confused, right?
Yes.
Yes, Sasi.
Yeah, I understand. I understand. Why? Because by following these slides, okay, these are not in order. So my explanation also it went in different order. Okay, we'll do one thing. We'll wind up for today. Okay, I will explain you the same thing on Monday itself. Okay, in proper way. I will arrange these things also in proper order. Okay, is it fine?
Yeah.
Okay, fine.
Yes.